In this video, we are going to continue our discussion of 11.4, the cross product. We're going to see it in an application here. It actually will help us find the area of a triangle and parallelogram. So let's begin our discussion on how. Area of a parallelogram, if you don't remember, it's here on the screen. It's base times height, which means I need the length of u. V is not the height, right? It's going to be h. So I really need to find out what h is, and we can use trig to do this. I have theta, I have h, and then I also can use the v, because v is part of that triangle there, the distance of v. So h, I'm going to do it up here, h is equal to, or let's start with using trig. I have the opposite over hypotenuse, so that is sine of theta equals h over the magnitude of v. That tells me that h is equal to the magnitude of v times sine of theta. Okay, so the area here for a parallelogram is going to be base, all right, the base is the magnitude of u times the height, which is the magnitude of v, times sine of theta, all right? This should ring some bells in your head. This is actually the cross product. It was the definition from the last video in the sequence. The last video has that definition. So I can find the area of a parallelogram by just finding the cross product and taking the magnitude. Right? A triangle, if we think about it, we just take our parallelogram and we cut it in half. So I'm going to put triangle here. We probably should have put parallelogram here. I'll just do A of P. The area of the triangle is 1/2 times the cross product of U and V. So if we wanted the triangle, we would do that. If we wanted the parallelogram, we would do it without the half. How these show up in application problems, let's take a look at this example. So let's find the area of triangle PQR given the 3 points of the triangle. It would be really nice if I could just find 2 points, 2 vectors, because if I had 2 vectors, I could take the cross product and get an area of the triangle. So let's find PQ. So that is taking Q minus P. -2 minus -4 is a +2. 3 minus -1 is a 4. 2 minus 2 is 0. We also need a PR. We want them from the same place. So negative, did I just do PR? No, okay. I got 2, 4, and -3. It's very similar, but not exactly. All right, so to find the area, I'm going to do PQ crossed with PR. And we'll go from there. I, J, K. And we got 2, 4, 0, and 2, 4, -3. All right, cover up the first column, first row, and we get 4, 0, 4, -3, I, minus, big minus is one that people miss, for a second column, first row, we write down what's remaining, J, plus, we do the third column and first row, and we got 2, 4, 2, 4, K. All right, we keep working this out. I got -12 minus 0, I. That's using the diagonal thing, right? 4 times -3 minus that. Minus, I got -6 minus 0, J. And then I got 8 minus 8, K. So we get -12, I, plus 6, J, and 0, K. We can put it there if we'd like. We don't have to. All right, then we need the magnitude of that vector. All right, the magnitude is the square root of 144 plus 36. All right, that gets me a square root of 180. If I break that down radical-wise, I get 6 root 5. All right, they said the area of a triangle is 1/2 times that, 6 root 5. That ends up being 3 root 5. Now, that was a lot of work for an area of a triangle, maybe, is what we're thinking. But this actually took care of that triangle. I didn't have to think about the way the triangle was lying on the graph. I don't have to think about trying to make a right angle and trying to find the height of said triangle. All we did is just compute it. All right, so it is helpful. The cross product does get faster the more you do. I want to look at a couple properties of the cross product before we move on to our final topic. The big thing here, U cross V is orthogonal to both U and V. We also have number 2. That was a new identity that we came out with. Using that identity, we figured out number 3, that if U cross V is 0, then U and V are scalar multiples. And I'm going to go ahead and say this means they are parallel. All right, that's what scalar multiples mean. And then the last thing is the cross product. If I take the magnitude of a cross product of 2 vectors that are both sides of a parallelogram, that gets me the area of that parallelogram. All right, well, that's it on basic one. We have one more application that will be in the next video.